Hi, my name's James Dean with Oxygen8, and I'm here today to talk to you about energy recovery technologies. Energy recovery technologies are used in ventilation systems to, number one, save energy, both thermal energy and sometimes latent energy as well, and secondly, to reduce the size of your cooling or heating system. There are two main types of energy recovery technologies. There's wheels and then there's cores. So I'll talk first about wheels. Here's an example of a small segment of an enthalpy wheel, which goes inside the air handling unit or ventilation system and spins around. Inside, the material you'll have here is either aluminum or plastic, which does the heat recovery. And in an enthalpy wheel, this material will be coated with a desiccant, which absorbs and desorbs the humidity to do the latent recovery. There are advantages and disadvantages of wheels. The two main advantages, one, you'll see that they're quite thin, so reduces the length of the air handling unit, and secondly, are quite cost effective in large air handling units above 10,000 CFM. The two main downsides for wheels are, one is you have motors, you have belts and seals that can require maintenance or could fail. The second is wheels will typically have higher crossover and have an EATR of somewhere between 1 and 10%. The second technology that we're going to talk about are cores. And there's two main types of cores. There's ERV cores and then HRV cores. So ERV cores will have a membrane inside. In this core here, you'll see the blue material is a polymer membrane, which transfers both water vapor and heat, or does sensible recovery and latent recovery. This is really used in hot, humid climate zones and cold, dry climate zones, where you want to dehumidify that humid air in the summertime or keep the humidity in the building in the wintertime. The second type is an HRV core, which does sensible only or heat recovery only. And here you can see it's typically made of an aluminum material, or in this case here is made of a plastic material. And it again does only heat recovery and is typically used in moderate climate zones like the west coast of Canada and the United States. You'll also see there's a couple different shapes of cores. This one here is a cross-flow core, and the reason why it's called a cross-flow core is the two air streams are perpendicular to each other. A cross-flow core will typically have a total recovery efficiency of somewhere between 50 and 55%. More recently in North America, we've started to see these high-efficiency counterflow cores, which are the hexagon shape, and the two air streams are parallel and opposite to each other. So you'll have the return air go through this side of the core like this, and then you'll have the outside air go through to the supply side of the building here. Typical efficiencies of the counterflow core are somewhere between 65 and 75%. So when choosing energy recovery technologies for your project and deciding whether it should be a wheel or a plate, sensible or latent recovery, it's really important to look at the specific application. Understand the climate zone that you're in, the size of the air handling unit that you're working with, and whether low maintenance and low crossover is a requirement.